So historically, and I believe these are still pretty commonly used, are these pedigrees. And really they're family trees, but they're specifically family trees that are looking at the interrelationships between parents and their children across these generations for hereditary conditions. They're incredibly useful when you're talking about having huge amounts of information. So, really big families, really good records. Um, they do sort of start to lose their value when you don't know much about your extended family. Or you're in a situation where you were adopted and maybe don't know that family history at all. This is a particular pedigree. This is a pretty good one. This one's actually of the British royal family, and this is tracing specifically hemophilia, so it's a sex-linked trait. So if you really start paying attention, you see it's overwhelmingly male. A couple of things I wanted to point out here are just the way that it's built. So you'll get sort of generation lines. They'll put Roman numerals for each generation across them. You've got certain symbols. We'll take a second and see what those are all about. You've got these connections, these lines to who matches to who, who's married to who, whose children are who. And then you often will have a key down here so that you understand what those symbols mean. In just a second, I'm going to show you some of the common symbols. I will tell you, though, that those keys are huge. Those legends are huge in reading pedigrees appropriately because although there's a certain set of commonalities, common symbols, there's a lot of license to kind of do what they want, so long as the key is there and the key is accurate. So just be aware of paying attention to what that particular producer of that pedigree intended for that information to display. So when we construct pedigrees, these are pretty standard. You've got your females as circles, your males as squares. If I take a look at offspring, specifically identical twins, these will often be marked, particularly your identical twins. Fraternal twins you may see as this branch like this. Maybe that gets used, maybe it doesn't, because genetically speaking, those fraternal twins are not any more or less genetically identical to each other than siblings that would have been born years apart. Your identical twins, however, those are pretty important ones to connect. And so you may come across symbols that look like this because they're genetically identical. They came from a single egg, single sperm fertilization process, and as that cell began to divide, they split. So genetically, and remember that's the point to these pedigrees, we're tracing genetics. I want to know that they are genetically identical. Some other connections you may see, male to female across the board, single horizontal line, we're talking about a marriage line. It's not necessarily that they have to be married, it's sort of an antiquated term, but they are going to ultimately be connected and then probably produce children from there. So you get those sibling lines that drop down from that. So here would be their set of parents, and here would be the children that they produce, which means these would all be siblings to each other. Some other common symbols, I would say this is pretty standard. Shading in either that circle like I see here, or it could be a square that's shaded in, meaning that it's a person, an individual who's affected for the trait that they are tracing. You may come across this one where there's a dot in the middle for an X-linked characteristic. Maybe that gets used, maybe it doesn't, so check the key. And if you're building the pedigree and choose to use it, make sure it's something that you put in that key. Autosomal carrier, also another relatively common one where you shade in half the shape. And if you see a line through that shape, then that would indicate a particular person who is deceased should they care to show that particular information. So here's probably the biggest challenge. How do you interpret it? Because once you can interpret it, you should be able to backtrack and build one. So really it's a matter of breaking down reading pedigrees into two pieces, at least for our level of depth. So if I look at a pedigree chart, first off, I want to know, is the characteristic that I'm dealing with autosomal or is it sex-linked? Is it X-linked? If I'm overwhelmingly seeing only males or the vast majority of individuals affected are male, then I'm probably dealing with an X-linked trait. If I'm getting closer to a 50-50 ratio between men and women who are showing the disorder in my pedigree, then it's more than likely an autosomal characteristic. So if I look at this, right, I've got males and females in all of my generations. And in fact, this one's made pretty commonly, or I should say, it's made to really stand out. If I look, there's 3 males, there's 3 females, so we clearly have a 50-50, and this one is an autosomal example. Once I determine whether it's autosomal versus sex-linked, then I need to determine, am I talking about a dominant or a recessive trait? If it's dominant, then that means that every parent has to have, or I should say every generation has to have a parent with the disorder. So at least every generation there has to be one affected person. If the disease is recessive, then there's the potential for it to skip generations, meaning that neither of the parents have to have the disorder, even though their child does, because they could both be heterozygous, they could both be carriers. So if I look at this one, here's where I see a situation where every generation I've got an individual in that generation who's affected, at least one. And so this would be a dominant situation. This one, on the other hand, I don't have anybody in that first generation. It skipped it. But I do in the second and the third. And so this one would have to be a recessive trait.